we can find the number of electrons. Now that's beginning to record. Today, we are now moving towards the new thing. If you have any questions, kids, please let me know. Let me change the internet as well because I think it slowed down. Wait a second. Damn. Damn. Wait a second. I don't know what happened here. Okay. Anyway, what's the issue with this? Wait a second, kids. I don't know what happened here. I cannot zoom in. Auto rotate page company change the go to. Beta, wait a second. Somebody at my office did something weird. Hello. Yes, ठीक ठाक क्वेश्चन सर मैं आपसे ना रात को 10 बजे तक आप कॉल करूँगा ठीक जी जी wait kids somebody ना locked the orientation उमर तुमने इसका जूम लॉक किया है कौन सा इसका जूम क्यों नहीं हो रहा इसके ऊपर वन गुड नोट्स पे नहीं मैंने तो ऊपर नीचे हो रहा है ये क्या किया फिर नहीं अभी साइफ ने ड्राइंग की थी उसको भेजो क्या किया इसके साथ जब तुम लोगों को पता है ना छेड़े को बेटा इस तरह की हरकत है वेट अ सेकंड किds Okay, kids, now it's zooming. Sorry about that. So then let's look at the right, please. Electromotive force, and also write the potential difference. Now, these two will have two mark definitions. Yes, please. And the first mark will be for writing work done per unit charge. This is the first mark. The second mark will be when you write by the battery to move a charge round a complete circuit. This is what you got to write. Now EMF, like you can see from the formula, the definition, it is work done per unit charge. Or you could also write it as energy per unit charge. The SI units for these are joules per coulomb or volts. Now for potential difference, the first part is the same. You always say work done per unit charge. In dissipating electrical energy to other forms across any 2 points in the circuit, like that. Now for this one, potential difference is work done per unit charge or energy per unit charge as well. Same formula, everything is same. Just the you say the definition is different because they have different concept. And the SI units would be joules per coulomb or volts. I'm going to explain what these are, but before that, I just want to tell you that these two are scalar quantities and they are measured by a voltmeter. The symbol for voltmeter is like V and like that. Please write this down and then I'm going to go forward. Then next. If you place cell or battery, the resistor 1. Now, if you put a voltmeter across it, this is going to give you the EMF because EMF is basically the total energy per unit charge that the battery is supplying so that a charge can complete a circuit and charges move in form of current. So the current goes, and then when the current basically reaches this point, so at this point, because it has not entered the resistor, the charges have 12 volts of potential at this point. Do you guys understand that? Now, suppose that out of 12, this resistor needs a potential or it uses the energy or transforms the energy to other forms by 2 volts. So that means at this point, the potential that is left with the charges would be 10 volts. Do you understand? So basically between any 2 points, the potential difference is the voltage difference that is being transformed to other forms in the circuit. Is it clear, everyone? Asma, Furkan, Salma, Shazid, Dirwa? If you have any questions, please let me know. Now suppose the next one needs 6 volts, or it converts 6 volts. That means that right now we had 10. So when it uses 6 volts out of it, transforms into other forms. So it means 4 volt must be remaining. So the potential at this point has to be 4. And obviously the last one will use all of it. So here the potential left is 0, so it will just go back. So these numbers that I've written right here, you guys need to understand that these numbers are potential, and across any 2 points, when you find the difference of that, that gives you the potential difference. Like for example, if you say I'm going to find the potential between this point and say this point, so that would mean that this should give you a potential difference of 8 volts, because 4 minus 12 has to be 8. Is it clear, everyone? Any questions? Please let me know. Yes, Salma?
If like 0 volt is then does that mean the circuit is short circuit and no EMF relating to the battery?
Salma, there is so much interference in your voice, I couldn't understand. Could you write it down, please? No, 0 volts means that in a circuit, basically, whatever the voltage the battery is supplying, it gets divided, right? So all of it needs to be 0. So as, yeah, you could say that, because now the voltage finishes, so those charges are going to go back and return with uh, new energy to supply. Is it clear? You're right about that. Circuit doesn't stop working. It's just that the energy in the charger is finished, so charges will go back to the battery to get refreshed. Understood? All right. Now, this point of the potential is so important because in a lot of cases, they are gonna ask you a lot of questions related to these in this, and because this is something new that you haven't done in your IGs, so you guys need to just pay attention. So remember that current always goes from a point of higher potential to a lower potential. And why it is so easy to remember, because you see, like we used to study that energy always travels from high concentration to low concentration or something like that. So it's the same way it goes. Like for example, suppose if you have a resistor, on one side of resistor, you have, I'll give you 4 examples of this so you guys do not make a mistake. So let me just copy 4 of these. All right. So in these four examples, suppose one potential on this side is plus 500 volts and you have 0 volts. So obviously the current is going to go like that. If you have plus 500 volts and then you have plus 500 volts on either side, so because the potential is same, so there is no potential difference. So current in this one will be 0. So current cannot go if the potential always goes from higher to lower. Now, for example, if this is 0 volts and this is negative 200 volts, so the current will go now from negative 200 to 0 because 0 is higher potential than negative 200. And then even if it's negative 500 and this is negative 200, so obviously negative 200 is a higher value than, sorry, the current, I made a mistake. Current should go like that, from higher to lower. And now, as you can see, the negative potential is more. So it will go from higher to lower. So the current will be like that. Is it clear, everyone? Let me know if there is a question here. Now, generally, questions like, these are given. So suppose there is a question like that, which says points A and B are connected with an ammeter which shows a zero current. So they have given you a circuit PQ and RS, and then there's an ammeter connected here between points AB. Now here they say the current is 0 and they say what is the reason for this. Alright, so this is the question. Now, if it shows there is 0 current, so there is a wrong answer and there is a right answer that generally people write, and it is rampant throughout the examiner reports. A wrong answer would be if you say something like that ammeter has infinite or large resistance. Do not write that, please, because an ammeter doesn't. The right answer for a question like this would be that the potential of A and B must be equal. Hence, current cannot move between A and B like that. Alright, so you guys can always remember this. This is the only logic that you need to follow along. If you have any questions now, please let me know, please. Write it down, please. Yes, Shazir, everything is clear? You understand? Furqan, what about you? All right, kids, done. Should I go forward, please? Okay. So now we're going to talk about electrical resistance. Now, generally, resistance is believed to be the opposition of flow of current. Resistance is directly proportional to voltage, means potential difference, and resistance is inversely proportional to current in any circuit. So that is the reason we follow like R equals to V upon I. But this equation, you need to be very, very careful because this equation is only true for ohmic conductors. We're going to learn what ohmic conductors are later. Now, the next thing they're going to ask you is to define ohm. And when they do, you basically need to write that 1 ohm is the resistance of a component when a potential difference of 1 volt drives a current of 1 ampere through it. So again, the keywords in this would be the units of each quantity: ohm, volt, and ampere. All right, kids. Now, speaking of that, then let me see how much page we have left. Okay. So then we have a very popular thing, which is a derivation of the origin of current. And this is very, very important. They're going to say derive an expression I equals to NAVE. All right. Before we do anything, I would like to explain what exactly all the quantities are. So you have a wire or a conductor that you're looking at. Within this conductor, you have a cross-sectional area A. You have a length of the conductor, obviously, L, and the current is passing through it. And naturally, this conductor will have electrons in it that help us, pass the current. Now, I in this obviously is the current passing. N is the number of electrons per unit volume. This N in the short form is also called electron density. I'll explain what it means. Remember, electron density is a unique value to each material. So copper will have a different density, iron will have different, aluminum will have different, and so on. Then you have A, which is cross-sectional area. V is the drift velocity. E is the charge on an electron. All right, write this down, please, and then we'll start the derivation. All right, kids. Now first off, I'd like to tell you what exactly this electron density thing is. It basically means that if you cut a section of this wire, and that section of wire is of 1 meter cube of volume, so we want to count how many electrons exist there. Obviously, the greater number of electrons in that a unit volume would mean that it's a better conductor. Do you guys understand what I'm saying? So it's like that. Now, first of all, we'll start from here. Let me change the color. Current, initially I defined as charge over time. So you guys can, as you know. Now we don't know what the charge is, but we do know that we can find it if we could divide, we could know what is the charge over volume. Now, what is the charge over volume? Obviously, N is the number of electrons per unit volume. And then if I multiply the charge on each electron, it's going to give me the total charge per unit volume. Do you guys understand that? Okay. Then what you do? Okay. So let's suppose you have N is 10. Let's suppose Salma. Okay. If N is 10, it means there are 10 electrons in a unit volume. Do you understand that? Apply charge on an electron like that. So what will I get? I will get the total charge per unit volume. Is it clear? Each electron has this charge, and there are 10, so it will be the total charge over volume, right? So this is what I've done. N is basically how many electrons are there in a unit volume. And if I multiply the charge on each electron, I will get the total charge per unit volume. Is it clear? Now, in the next step, I want to find the charge only. If I want to find the total charge in the whole wire, what can I do? I will multiply this value. So this is basically the total charge in a unit volume, which means 1 meter cube. If I multiply the total volume of the wire itself, what do I get? I get the total charge in the wire now. So let's suppose I have 10 electrons. I multiplied their charge together in 1 meter cube. If I have a wire of 10 meter cube, so if I multiply 10 meter cube with this, so I'm going to get the total charge that this wire contains. Is that clear, everyone? Okay, good. Now, the next thing I got to do, step 4, I got to find the volume. So volume is area times the length. So cross-section area of the wire times the length. Now, I'm going to do step 5. In step 5, what I'm going to do is, I know the total charge now will be N times E. Instead of volume, I can write it as A times L, like this. So I've just replaced volume with its things. Then, because I have the total charge, I can put it back in the equation 1. So 6th step is going to be, because current now is charge upon time, so I can write it as N times E times A times L divided by T. So this is what I got. All right, so if you notice that we have length over time here, right here, which is just velocity. So then I can write in the 7th step, I equals to N times charge is E times A times length over time is going to be V, which makes it the equation that we need, I equals to NAVE. Some people like to write it like this. Other people like to write it as NAVQ. It is the same thing because Q is the same symbol as charge on an electron. So it's all right if you write that. Is it clear, everyone? Any questions, please let me know. Please have a look. Please write it down. This is so important. This derivation comes of 4 to 5 marks, and you don't want to lose it. It's a big chunk of exam percentage. All right, kids. So I guess that's all for today. If you still have any questions, any doubts, please let me know.